Hi, welcome back. So let's have another example. So say we have g of x all over 4x to the 4 plus 25. Okay. So we have integrand like this. We have x dx all over 4x4 plus 25. As you can see here, we cannot immediately take the inverse formula by this example. So we need to transform this in order for us to make our or to make a form similar to our formula, so we can directly use it. Okay, so first simplify this integrand by doing some algebra. So here, as you can see, we don't have the square root sign, and the most similar form to this one is our second formula, which is equal to du all over a squared plus u squared. Okay, so we can see that we have a sum constant here and some squared of some variables here, and then the du or the derivative of this variable u here. Okay, then let's try to make some modifications or transformations in our integrand. So since if you want, then you can rewrite this to make the what do you call this, the constant first. Okay, but this is not a problem as long as you understood that it can their place can interchange, but always remember that the constant here is positive as well as the variables here, so they are both positive, so you can change their place, or you can interchange their place. So in order for us to easily see that it is now on this form, you can interchange the place of 25 to 4x4. So we have 25 plus 4x4. Then you can now once again let's do the algebra in order for us to get the value of a, which is raised to 2. So let a squared is equal to all of this term. We have 25, and then how can we get the value of a? Because we only need the value of a. Okay, so by doing so, we need to get the square root of this whole term here. So by getting the square root, we have a, and then the square root of 25 is just 5. Okay, so the value of a is just 5. Then we need, on the second part, we need the value of our u, which is raised to 2. Then let us equate our u squared here as equal to 4x to 4 raised to 4. Then by getting the square root, we have u, and then the what do I call this, the square root of 4 is just 2. Then the square root of this x to the 4 is just x squared. And if you want to check, then you can square this. A squared just a squared, 5 squared is just 25. Or if you gonna square this, u squared is u squared, and then 2 squared is 4, and x squared is just 4. Okay, So I think we're on the right track. That is just for checking. Okay. But once again, we need the derivative of the u. So need to take the derivative of our u. And the derivative of our u here is we have 2 times 2, we have 4x and then d of x. Okay, so the derivative of u is du and the derivative of this term is just 4x dx. Then going back to our main or to our integrand, we can now use the change of variable. So we have 25, which is equal to a squared, and we have 4x squared, which is equal to u squared. Then our x dx here, we have x dx here, we can get our x dx here, but we need to divide it by 4. So we have 4. So the value of our x dx is just equal to du all over 4. Okay, now we can now substitute the value. So what we have here is this. It's just we have the integral of the x dx, which is equal to du all over 4 all over 25, which is a squared, plus 4x to the 4th, which is u squared. And then simplifying further, we have 1/4 integral of du all over a squared plus u squared. And as you can see here, we can now we are now on the form wherein we can now directly apply our formula. This one can now apply our formula, which is then equal to 1/4. We have 1/4 here outside, then multiply by the integral of this term. So the integral of this is 1 over a arctan u all over a plus c. Okay, so we have 1/4, and right after that we need to bring back the value of our a and u. Bring back value of a and u. So we have 1/4. 1 over our a is 5. 1 over 5. Arctangent value of our u is 2x squared, and then once again our a is 5, then plus c. So this is now our final answer. Okay, so once again, let us review. We start here, so we need to integrate the x dx all over 4x 4 plus 25. So you cannot directly use the formula, but we can do the algebra. Okay, so by doing so, we first change the place of the constant in the 4x4. Then we let that the a squared, this whole term here, is equal to our a squared, which is equal to 25, and then we get the square root of this in order for us to get the value of a, which is equal to 5, and as well as to our u. And then we need to take the derivative of u, or the du. That's why we take the derivative of our u here. Then by doing that, we notice that on our integrand we only need x dx. That's why we need to divide this whole derivative here with 4. That's why we came up with du over 4. And then we apply, then we place the 1/4 outside the integral sign, so that we can now directly use the formula, which is in a form of du all over a squared plus u squared. And then by doing that, we bring back the value of our a, which is 5, and then our the value of our u, which is 2x squared, and then the do not forget the plus c sign at the end. So that's all for this video. I hope you learned something, and see you next